All right, lesson 1.6 is all about parallel and perpendicular lines. Now remember from the past that two parallel lines will look like this, two lines that will never intersect. Key term: parallel lines, lines in the same plane that will never intersect. Perpendicular lines, on the other hand, are lines that intersect at a right angle. So something close to this. Okay, all of these angles are right angle, 90-degree angles. Okay. From the lines that we've been looking at, our linear equations, we can find parallel and perpendicular lines. Okay? Now when we do that, we always need to find the given slope first. So I want you to write this down, put a star by this somewhere. When you are given the first line, so let's say we started with this one on top, we need to know that slope first before we can find a line that is either parallel to it or perpendicular to it. So find the slope first, then you can figure out the perpendicular and parallel lines. Facts about the slopes of these lines. Parallel lines will have the same slope or equal slopes. So if this line had a slope of 1/3, this line would also have a slope of 1/3. Perpendicular lines, on the other hand, have opposite reciprocal slopes. Now these are two separate things. Opposite means one thing, and reciprocal means something else. So let's say this line here had the slope 1/3. Well, opposite would say, as we go to the new slope, opposite makes it negative, because this was positive, so it's negative. Reciprocal means flip those numbers. So 3/1. Negative 3/1, or -3. If this line was 1/3, this line would be -3 for their slopes. So perpendicular, opposite, reciprocal. Parallel, equal. They're the exact same slope. Okay? So as a little example here, if you have this equation, y equals 3/2 x plus 1/2, always need to find our given slope first. So the slope of our given equation, from this equation, we would know right here, our slope is 3/2. Okay? If I wanted a line that was parallel to this equation, its slope would also be 3/2. It has to be, because every parallel line has an equal slope. Now if I wanted a line that cut this line at a 90-degree angle, it would have to be perpendicular, so its slope would be opposite reciprocal. Instead of positive 3/2, it would be negative 2/3. The 3 and the 2 would flip, and instead of positive, it would be negative. So a parallel line would have this slope, a perpendicular line would have this slope. Note, you can write the equation of a line parallel or perpendicular to a given line if you know a point on the new line, an equation of the given line. So I'm going to draw what that means. If I know the equation for this line, and let's say I wanted to know through this point, I want to figure out a parallel line. So I'm going to do kind of a dotted line through here. So I would first need to know from this line, what is my slope? Because that'll tell me what the slope of this line is. Once I know the slope of this line, if I know where this point is, I'd have a point and a slope. I can write the line, or the equation of this line, from that information. Okay, so that's all they're saying here, is if we know this line, the equation for it, and we know where this point is, we can figure out the equation for this line, that's perpendicular, or the equation for this line, one that is perpendicular to it. We can find either of these equations. So let's go over an example of that. If you need to write the slope-intercept form of the line that describes each of these examples. Now note, question has come up before, can you just find the slope that you need to use, then use your point-slope form, like we did in our last video, then use, from the point-slope form, change it into a slope-intercept form? You can do that. These steps, I think, will be a little bit faster. So, or you can do it this way. I'm going to show you what I think is a little bit faster way to do it. So on this example, we're going through the point -3, -5, and we're going to be parallel to this line, the equation right here. So we're going to use our slope-intercept form, the y equals mx plus b, plug in the x and y values that we know. We get those from right here. This is an x value, this is a y value, so we can plug them in as x and y. We can also plug in our m value, the slope, from this equation. Okay, but it depends on whether or not this is parallel or perpendicular. So we'll go through each of these steps one at a time. So first, because it's parallel, we want to know what is parallel to the slope 7/3. Well, parallel means they're equal, so it would also be 7/3. Now we know our m of our new line, and we know that it's going to go through this point, -3, -5, so we just plug those in. Y equals mx plus b. Our y comes first. Here our y is -5, right here. Y equals mx plus b, so m comes right here. We know that it's 7/3 from right here. X is -3 from right here, but we don't know where our y-intercept is, so we call it b. Now at this point, to solve for b, we multiply these together and then subtract it from both sides, or take it away from both sides. So 7/3 times -3, suppose I can just move it down like this, will become a -7. To get rid of that -7, you can either think of it as subtract -7 or just add 7 to both sides. Add 7, which means that 2 equals our b. At this point, we know 2 equals b, and our slope is 7/3. So we have m and we have b. We have a full equation. The slope-intercept form is going to be y equals 7/3 x plus 2. So notice, slope-intercept form right here, and this was the original equation that we are working from. This line will not go through this point. This line is, we'd say, way over here, and we need to get through this point, -3, -5, which means we need this line to do it. This red line is this equation right here. That's the work that we did. We knew this line, it's right here. We knew this point, it's right here. To find this parallel line, we know it's parallel because it says right here, we did this work and found this information. This is the equation then. Let's try example 2. Again, it's going to go through the point -3, +2, so it's going to look like this. Here's some point. It's going to be parallel to this line right here. So here's the line. We need to find this equation then, parallel to the green line. To do that, we need to find the slope of this line, and then we'll find the y-intercept. So, to find the slope, we first look at this equation and say, what's the slope? Well, remember there's like a hidden 1 right here in front of the 1, or in front of the x. So for something that's parallel, it's going to have an equal slope. So it's also going to be 1. We plug that in for our slope here. Our y and our x for y equals mx plus b come from right here. Y is 2. X is -3. And the b is still unknown, so we use it as b. 1 times -3 is just -3. Add 3 to both sides, we'd say 5 is b. We now know 5 is b. 1 is our m, so 1 here, 5 here, which means the slope-intercept form of this blue line, the parallel line that we're looking for, is going to be y equals 1x plus 5. Or you don't even really need the 1. It would just be y equals x plus 5. And that would be our slope-intercept form of a parallel line. Example 3. So it's going to go through the point -5, -3, and it's going to be parallel to y equals 3. Now, there are some special cases we need to look at here. Y equals 3, well, there is no slope here because there's no x term. So remember, when y equals 3, that's just a horizontal. Oh, that's not quite horizontal, but maybe I can turn it. There we go. This is just a horizontal line at 3. Okay, anytime there's a y equals something, it's just a horizontal line. If this was an x equals, it would be a vertical line. Okay, for you to be parallel to a horizontal line, you should also be a horizontal line. If you're going to be parallel to a vertical line, you should also be a vertical line. So our special cases, whenever we have y equals something and there's no x variable, it's a horizontal line and our slope is 0. Whenever x equals something alone, so there's no y variable, that's a vertical line and our m is undefined. There is no slope. So if that's true, if we're going to be parallel to horizontal, where our slope is 0, then our new slope would also be 0. When we're parallel to vertical, where our slope is undefined, our new slope is also vertical. It's also undefined. So in this case, we want a line that's parallel to a horizontal line. So our new line, and I'm going to draw in red, should also be horizontal. And we know it goes through this point, -5, -3. Which means all of these points should have the same y value, the same -3 value. So it has to be y equals -3. It has to be, every time. We're going to try one with perpendicular, for example 5. So we're going through the point -2, 1. And we are going to be perpendicular to this y equals 1/3 x plus 4. So again, we're going to use the slope-intercept form, plug in the x and y values from the point, and the m that we found from the other equation. So if this one, the m value is 1/3, and we want perpendicular. Remember, perpendicular is opposite reciprocal. So if this was positive, it should be negative. If this was 1/3, it should be 3/1. So it'll be -3/1. Or you can call it -3. That found our m value. To find our b value, we plug in all the information we know. Here's our m. It was -3 from right here. Our y value we'll find from the point. We'll use 1 as y, -2 as x. And b is still just b. We haven't solved for it yet. -3 times -2 is 6. So 1 equals 6 plus b minus 6 from both sides. -5 equals b. So we found out -5 should go here. We found out -3 should go here for m, which means our slope-intercept form should be y equals -3x plus -5. If you want to rewrite that one, you can also call it y equals -3 x minus 5. You don't have to say plus a negative. You can call it -3x minus 5. Either one will work. Example 6 then. We're going through this point for -3, and it's going to be perpendicular to y equals 0. Now remember, y equals 0 is one of those special cases. Since it's a y equals, it's a horizontal line. If it was x equals, it would be a vertical line. But this is y equals 0, so it's going to be a horizontal line, and we need perpendicular to that. If you want to be perpendicular to horizontal, so here we have a horizontal line, we need something that is perpendicular to it. Notice that makes a vertical line. So to be perpendicular to it, it will be vertical. Remember, any vertical line has the equation x equals something, some number. So if it's vertical line, and it goes through this point, which is 4, -3, all of the x values should be the same. So all we have to do really is look at that x value. Since we want a perpendicular line to a horizontal, the line has to be vertical. Our new line goes through the point 4, negative 3. It is vertical. All of those x values have to be 4. So our line is x equals 4. That would be the perpendicular line to y equals 0 going through the point 4, negative 3. And that'll actually be it for our last video.